Today, I will discuss some questions on differential equation. I'm not saying that these questions are the exact questions which will come on JAM or competitive exams, but I can say that these questions will surely help you in the future when you will appear in competitive exams, that will be JAM or TIFR or M.SC Entrance. So I have some questions on differential equation. I have a set of questions. I will surely discuss it. I will give you the method of solution and definitely the answers. So the first question is, if 2x equal to y to the power 1 by 5 plus y to the power minus 1 by 5 and x square minus 1 d2y dx2 plus lambda x dy dx plus ky is equal to 0, then what is the value of lambda plus k? Lambda plus k is equal to option A minus 23, option B minus 24, option C minus 26, option D minus 26, option C minus plus 26, option D minus 26. The equation which is given is 2x is equal to y to the power 1 by 5 plus y to the power minus 1 by 5. So y to the power minus 5 means 1 by y to the power 1 by 5. Y to the power minus 1 by 5 means 1 by y to the power 1 by 5. And if we simplify it, it will become y to the power 2 by 5 minus 2x into y to the power 1 by 5 plus 1 is equal to 0. Now, let's see. Look at this, y to the power 2 by 5. I'm taking it as y to the power 1 by 5 whole to the power 2 minus 2x into y to the power 1 by 5 plus 1. So this is a second degree equation of y to the power 1 by 5. This is a quadratic equation of y to the power 1 by 5. Y to the power 1 by 5 to the power 2 minus 2x into y to the power 1 by 5 plus 1 is equal to 0. So applying the Sridharacharya, that rules, we'll get y to the power 1 by 5 is equal to 2x, that is minus b plus minus root over b square minus 4ac by 2a, that is 2x. Here a is equal to 1 if we compare it with ax square, a y to the power 5 to the power square. So a means 1, b is equal to minus 2x, and c is equal to 1. So y to the power 1 by 5 is equal to minus b, that is minus of minus 2x, that is 2x plus minus root over b square. B square means 2x square, that means 4x square minus 4. AC, A means 1, C means 1 by 2A, A means 1. So that will become x plus minus root over x square minus 1. Take log. After taking log, this will become 1 by 5 log y, and I have put it 5 here. Log of is equal to log of x plus minus root over x square minus 1. Name it as 1, at the equation 1. If we differentiate 1 with respect to x, that will become 1 by y. If we differentiate log y, that will become 1 by y dy dx is equal to 5 into the differentiation of this term is 1 by x plus minus root over x square minus 1, and the derivative of x is 1 plus minus, the sign is given here. The derivative of root over x square minus 1 is 1 by 2, 1 by root over x square minus 1, and the derivative of x square is 2x. If we cancel 2, that will become 5 into 1 by plus minus root over x square minus 1. Taking root over x square minus 1 in this side and taking y in this side, this will become root over x square minus 1 dy dx is equal to 5y. Taking the squares in both sides, this term will become x square minus 1, the root is gone, dy dx whole square is equal to 25y square. Now, I'm numbering this equation as 2. If we differentiate 2 with respect to x, again we have x square minus 1, the derivative of dy dx whole to the power 2 is 2 dy dx, and the derivative of dy dx is d2y dx2 plus 2x. First we keep this term constant, then x square minus 1 is x square, keeping this term constant, this will become x square minus 1 into, if we derivative this term, then this term will come, plus taking dy dx whole square constant, we should differentiate x square minus 1, that is 2x, is equal to 25, the derivative of y square is 2y into dy dx. Now cancel 2 into dy dx from both the side. We have x square minus 1 d2y dx2 plus x dy dx minus 25y is equal to 0. Now if we compare this term with the given equation, the given equation is x square minus 1 d2y dx2 plus lambda x dy dx plus ky is equal to 0. So the lambda becomes 1 and the k becomes minus 25. So lambda plus k is equal to minus 24. The answer is B, minus 24. I hope you will understand it. The next question is question number 2. The question number 2, it is very important question and it is a conceptual question. The question is, consider the differential equation. Consider the differential equation dy dx is equal to ay minus by square, where ab greater than 0, ab is positive, and y0 is equal to y0. As x tends to infinity, the solution yx tends to option A 0, option B a by b, option C b by a, option D y0. So I'm writing these equations again. The main differential equation is dy dx is equal to ay minus by square. Or if we take y common, so it will become dy dx is equal to y into a minus by. So dy by, if we put this term here, y into a minus by is equal to dx. If we break this, so 1 by a, so I'm writing y into a minus by as 1 by y plus b by a minus by. If we calculate this, you'll see that this term is equal to y into a minus by. dy is equal to dx. Okay. So the integration of this term is 1 by a. If we multiply with a, so 1 by a and a, this will become 1 and the a will come here. Okay. So what the integration of 1 by a, y is equal to log y minus the integration of b by 1 by b minus y is equal to log of a minus by. The b will cancel. The integration of dx and a is multiplying here. So ax plus, I'm taking constant as log c. Now the next step is log y minus a minus by. We know the formula of log y, log a minus log b is equal to log of a minus b. I am just applying this formula. So log y minus b by b, log of a minus y. So log y minus log of a minus by is equal to log of y by a minus by is equal to ax plus log c. Taking the log c here in the left hand side, we have log y by c into a minus by is equal to ax. So if we write it as y by c into a minus by, it will become e to the power ax. Okay, the exponential form. Now there is a value that is given, that is y0 is equal to y0. So if x equal to 0, the value of y will become y0. So putting x equal to 0 in 1, so the value of y is y0 c into a minus by0, and e to the power a, the value of x is equal to 0. E to the power 0 means 1. So the value of c is, after calculating, I found that the value of c is y0 by a minus by0. Now putting the value of c here from 1, so we get a minus by. If we taking the reciprocal of this term, it will become a minus by y is equal to e to the power minus x by c. Why I am taking it as e to the power minus x? In the question, x tends to infinity is given. So if we take e to the power minus x, if x is tends to infinity, so e to the power minus x will become 0. Okay, so that's why I'm taking e to the power minus x instead of e to the power x. Now I'm putting the value of c. The value of c is a minus by0. So the putting the value of 1 by c, that is the reciprocal of this term, that is a minus by0 by y0 into e to the power minus ax. So a by y minus 1 is equal to a by by0 minus 1 into e to the power minus ax. Okay. So if we calculate, this will become a by by is equal to a by by0y minus e to the power x. So but if we take x tends to infinity, it will surely become e to the power ax 0, and a by by will be 1, so y will be a by b. Okay, so that is the answer, and the answer is b, y equal to a by b. The next question is number 3. The next question is number 3. U and v are two particular solutions of the equations dy dx plus px y is equal to qx. This is a first order linear equation. Dy dx plus px y is equal to qx, where px and qx are functions of x, and these are the continuous functions, where k for the arbitrary constant k. Okay, so k is an arbitrary constant. The general solution will be of the form. The general solution of this differential equation will be of the form: option A, y is equal to k into u plus b. Option B, y is equal to k into u minus b plus b. Option C, y is equal to k into u minus b plus ub. And option D, y is equal to u minus b plus kb. So the main differential equation which is given is dy dx plus px y is equal to qx. So we can write p and q instead of px and qx later. As u and v, which is said that u and v are the particular solutions of this differential equation. So putting u in the place of y and v in the place of y, we have du dx. As u and v are the solutions, we can put it du dx plus px u is equal to qx, and the next equation will get dv dx plus px b is equal to qx. We are numbering it as 1 and 2, and the main equation which is given, we are numbering it as 3. Now if we subtract the equation 2 from 3, we'll get ddx of y minus b plus, if we take px common, px into y minus b, qx and qx will cancel, it will become 0, is equal to 0. Now the next step is d of y minus b by y minus b is equal to px dx. I'm numbering it as equation number 4. If we subtract 2 from 1 minus 2, if we do 1 minus 2, we'll get ddx of u minus b. 1 minus 2 means ddx of u minus b plus px into u minus b plus px into u minus b. So similarly, after calculating or after simplifying, we'll get d of u minus b by u minus b is equal to ddx is equal to minus px into dx. This is equation number 5. Now in both the equations 4 and 5, the right hand sides are equal. So if we take the left hand sides, this will become also equal, and from the left hand side we'll get d of y minus b by y minus b is equal to d of u minus b by u minus b. So after taking the integration, we'll get log of y minus b is equal to log of u minus b, and the constant term we are taking as log k. So y minus b is equal to k into u minus b, and y will become k into u minus b plus b. So the answer is option D. Okay. Now question number 4. If y1 and y2 be the solutions of the equation dy dx plus pxy is equal to qx. If y1 and y2 is the solution of the differential equation dy dx plus px into y is equal to qx, and y1 is equal to y2 into z, z is another variable, then for any arbitrary constant, option A, z is equal to 1 plus a into e to the power minus integration q by y1 dx. Option B, z is equal to 1 plus a into e to the power integration q by y1 dx. Option C, z is equal to 1 plus a into e to the power integration q by y2 dx. And option D, z is equal to 1 plus a into e to the power minus q by y2 dx. So the given equation is dy dx plus px into y is equal to qx. We are numbering it as 1. Since it is given that y1 and y2 are the solutions of the equations 1, so we get dy1 dx plus py1 is equal to q, and similarly dy2 dx plus py2 is equal to q. As y1 and y2 satisfies 1, we will have, so we'll get this equations 2 and 3. Okay. Now if we subtract 3 from 2, we have ddx y2 minus y1 plus p into y2 minus y1. ddx of y2 minus y1, as we are subtracting 2 from 3, so we'll get ddx of y2 minus y1 plus p. If we take common p, y2 minus y1, q will cancel, so it will become 0 in the RHS, right hand side. Now ddx of y2 minus the value of y1 is given y2z. We are putting it y2z in the place of y1 plus y plus p into y2 minus the same is here. We are putting y1, the value of y1, that is y2z minus 0. ddx of y2 is there in both the terms, so we are taking common y2, and in the bracket the term will be 1 minus z plus p into we are taking y2 as common into 1 minus z, y2 into 1 minus z equal to 0. So now look at this term. Okay, ddx of y2 into 1 minus z. y2 is a function of x, z is also a function of x. So this term is a term like u into v. y2, we are considering y2 as u and 1 minus z as v. So if we take y2 as constant, so y2, we are taking y2 as constant. Now we'll derive 1 minus z in respect of dx. So this will become ddx of 1 minus z. Now 1 minus z, we are taking 1 minus z as constant. So taking 1 minus z, it will come out from the derivative, and ddx of y2 plus py2 1 minus z. Okay. Now the next line is y2 ddx of 1 minus z plus, from these two terms, we'll take 1 minus z common. Okay. So 1 minus z, if we take 1 minus z common, the remaining term will be dy2 dx plus py2 is equal to 0. Now we'll simplify it as, or we'll make it as y2 ddx of 1 minus z, this will become q from the equation 3. dy2 dx plus py2 is equal to q. So this will become q. dy2 dx plus py2 is equal to q. So we are putting q here. Okay. Now y2 to ddx z minus 1. Just taking the minus as common from both the sides. So it will become y2 into ddx of z minus 1 plus z minus 1 into q. Now d of z minus 1, as here is d of z minus 1, we are dividing this term with z minus 1. So d of z minus 1 and z minus 1 will come together, plus q y2. If we divide by y2, it will come here, q by y2 into dx equal to 0. Now taking the integration, it will become log of z minus 1 is equal to minus integration q by y2 dx, plus we are taking some constant as log a. As y2 is unknown, we can't integrate it. Okay, so we are writing it as simply minus integration q by y2 dx. Now log of y2, now log of z minus 1 by a is equal to minus integration of q by y2 dx. So z minus 1 is equal to a into e to the power minus q by y2 dx. It is as simple, and z is equal to 1 plus the remaining term. Okay, so the answer will be D. The next question is, the general solution, okay, of the differential equation dy dx plus df dx y is equal to fx df dx, where c is constant and fx is continuous, is, these are the options. Okay, the first option is y minus fx plus 1 into e to the power fx is equal to c. Option B, fx is equal to y minus c e to the power fx plus x. Option C, log of y plus fx is equal to xy plus c. And option D is log of y minus fx plus 1 is equal to c. So the given equation is dy dx plus df dx y is equal to fx into df dx. We are numbering it as 1. If we compare this equation 1 with our general equation of linear first degree, so you'll get that p is equal to df dx. Compare the coefficients of y, so df dx is equal to p, and q will be fx into df dx. Okay, so I'm writing here, I've written p is equal to df dx and q is equal to fx into df dx. Now for this type of equation, which is linear and first order, the integrating factor, if means integrating factor. So the integrating factor of the equation 1, there is a formula e to the power integration p dx. So here p is df dx. So the formula becomes e to the power integration df dx dx. If we cancel dx dx, it will become e to the power integration dx. Integration df means the derivative of f, and then the integration means it will be e to the power f. Okay. There is no need of adding constant here, because as this is a first order differential equation, we'll get a constant here, and for the first order differential equation, only one constant is needed. Okay, so the required solution is, the formula is y into if is equal to integration q into if dx plus c. So here if we have already found our if is e to the power f. Okay, so y into e to the power f is equal to integration q into e to the power f dx plus c. Y into e to the power f is equal to integration q, means the value of q is f into df dx, f into df dx into e to the power f dx. If we cancel dx dx, it will become f e to the power f df plus c. Now the left hand side is y e to the power f, and the right hand side is integration f e to the power f df. So the integration of f e to the power f df will integrate this as UV by parts. Okay, so after doing the by parts, we have the result e to the power f into f minus 1 plus c, the constant. So y will become f minus 1. If we cancel e to the power f, e to the power f, it will become c into e to the power minus f, and y will be f minus 1 plus c into e to the power minus f. So y equal to f means fx, the function of x, minus y plus c into e to the power minus fx. So this is the answer. The answer is A. Okay. So the question number 6 is the next question. Okay, this is a very important question, okay, and very conceptual question. If the next question is problem number 6, if y is equal to y1x and y is equal to y2x, if y equal to y1x and y equal to y2x be two solutions of the differential equation, this second order differential equation, okay, that is d2y dx2 plus px dy dx plus qxy. So this is the differential equation, and it is given that y1 and y2 are two solutions of this equation, okay, where px and qx are continuous and the functions of x. Then which of the following is true? The option A, y1 into dy1 dx plus y2 into dy2 dx is equal to c into e to the power integration p dx. Option B is here, you can see it. Option C is here, and option D is here. Okay, so which of the following options, which is true? Out of this following option, which is true, we will find it. Okay, how? So the solution is, as y1 and y2 are the two solutions of the given differential equation, so it will satisfy the given differential equation, and as a result, we are putting y1 in the place of y, as y1 is a solution. So the differential equation will become d2y1 dx2 plus px dy1. We are putting y1 in the place of y, dy1 dx plus qx y1 is equal to 0. Similarly, y2 is also a solution. Okay, so the differential, so y2 will definitely satisfy the differential equation, and the differential equation will become d2y2 dx2 plus px dy2 dx plus qx y2 is equal to 0. So I'm numbering it as 1 and this equation as 2. Okay, now multiply 1 by y2 and multiply 2 by y1. Okay, so this is a back calculation. Okay, we have to after seeing the options, okay, so we have to make it which of the following will true. So if you see the options, the options are like y2d, y1, d2, y1, dx2. So I'm taking, multiplying y2 with 1 and y1 with 2, okay, and then subtracting them both. So this will become y2 into d2 y1 dx2 minus y1 into d2 y2 dx2 plus px into y2 dy1 dx minus y1 dy2 dx equal to 0. Now this term is equal to d of the derivative of y2 dy1 dx minus y1 dy2 dx. If you see, if we derive this term, okay, so y2 is a constant, y2 into, it will become d2 y1 dx2, okay, y2 into d2 y1 dx2, and the next term will be d2 y1 dx2 as constant and d y2 dx, okay, sorry, the next term will be dy1 dx as constant and dy2 dx. Here minus this term, after differentiating, this term will become y1, if we take y1 as constant, y1 into d2 y2 dx, this is given, and minus dy1 dx dy2 dx. So the dy1 dx and dy2 dx, okay, this will cancel, because here we have another dy1 dx dy2 dx, this is plus, and here we'll get another dy1 dx dy2 dx. So both will cancel and the remaining term will be this. So this term is equal to d of y2 dy1 dx minus y1 dy2 dx plus px into y2 dy1 dx minus y1 dy2 dx. This term is similar. Okay. Now, this will become a very useful form, that is d of y2 dy1 dx minus y1 dy2 dx by, if we divide the differential equation by this term, okay, so this term is y2 dy1 dx minus y1 dy2 dx is equal to minus px. So it is quite easy that the derivative of the term which is given here is given above, okay, so it will be, if we integrate the term, it will be log of y2 dy1 dx minus y1 dy2 dx is equal to sorry, it here term of integration will be added, okay, integration minus px plus log of c1. So y2 dy1 dx minus y1 dy2 dx is equal to e to the power, we are taking constant as c1, so c1 e to the power minus px dx, okay. Now if we take c1 as minus c, we'll get our result and we'll get the option D, okay. So this is the solution of the question number 6. Now the next question, that is question number 7, okay. Okay, question number 7. There is a question on Wronskian, okay. So I think everybody knows Wronskian. Suppose suppose 1 x squared dot x to the power n are n plus 1 linearly independent solutions. So there are n plus 1 linearly independent solutions. That is 1 x squared dot x to the power n of an n plus 1th order differential equation. Okay, the order of the differential equation, which is not given here, but it is given that the order is of that differential equation is n plus 1, and there are n plus 1 linearly independent solutions. If W be the Wronskian of those functions, then which is true? There are 4 options. Okay, the options A is W is equal to n minus 1 factorial into n factorial. Options B is W is equal to 0 factorial into 1 factorial into 2 factorial into dot dot n factorial. Option C is W is equal to n factorial. Option D is equal W is equal to 0 factorial, 1 factorial, 2 factorial, dot dot n minus 1 factorial. So the formula of the Wronskian of the functions is, the first is 1, the first function, then x, x square, x cube, x to the power n dot dot. The next function is, the next row will be the first derivative of this term. So the first derivative of 1 is 0, the first derivative of x is 1, the first derivative of x square will be 2x, the first derivative of x cube will be 3x square, and the first derivative of x to the power n will be n x to the power n minus 1. The third row of the Wronskian will be, it is a formula that the second order derivative of 1 of x square, of x cube, of x to the power n, and so on. And the last term will be nth derivative. That will be 0, 0, 0. All the term will be 0 except this term, that is n factorial. Why it is in factorial? Because if we see this, the first term, the first term of the last column, okay, is x to the power n. The first derivative is n into x to the power n minus 1. If we derive n into x to the power n minus 1, we'll get n into n minus 1 into x to the power n minus 1. Okay, so by proceeding in this way, we'll get n into n minus 1 into n minus 2 dot dot 1 into 0, that will be 0. 1, that will be n factorial. Okay, so if we consider the diagonal term, the determinant of this term will be 1 into 1 into 2 into 6 dot dot n factorial. 1 into 1 into 2 into 6 into dot dot n factorial. So it will become 1 factorial, 2 factorial, 2 is 2 factorial, 6 is 3 factorial, dot dot n factorial. So the answer will be 1 factorial into 2 factorial into 3 factorial dot dot n factorial. That is option B. Okay. Now the next question, question number 8. The general solution of d2y dx2 is equal to root over 1 plus dy dx whole square is a, b are constant, okay, is y is equal to cos of h hyperbolic, okay, x plus a b. Option B, y is equal to sin h, sin hyperbolic, x plus a plus b. Option C, y is equal to cos hyperbolic, x plus a plus bx. And option D, y is equal to tan x hyperbolic, x plus a plus b. So the differential equation which is given is d2y dx2 is equal to root over 1 plus dy dx whole square. d2y dx2 is equal to nothing but ddx of dy dx. And here is root over 1 plus dy dx whole square. So I'm taking as it, or integration d dy dx by root over 1 plus dy dx whole square is equal to integration dx plus some constant a. Now look at this integration, okay. dy dx, if we consider dy dx as some variable z or some m, so dz by root over 1 plus z square. The formula is known. That will be sine hyperbolic inverse, that is sine h inverse dy dx, okay, z, sine h inverse z, that will be dy dx. And there integration of dx is x and plus the constant is a, okay. So dy dx is equal to sine hyperbolic x plus a. Now dy is equal to sine hyperbolic x plus a dx, okay. If we take again the integration, we'll get y is equal to the integration of sine hyperbolic is cos hyperbolic, so cos h x plus a plus some another constant b. So the answer is a, okay. And the last question, problem number 9, the last question of today's discussion is, so the last question of today's discussion is, let y1x and y2x be two linearly independent solutions of this differential equation. The differential equation which is given is x square y double dash, that is the second derivative of y, d2y dx2 minus 2x y dash x minus 4yx is equal to 0 for x belongs to 1 to 10. Consider the Wronskian yx, that is the determinant of y1 y2 y1 dash y2 dash, that is y1 into y2 dash minus y2 into y1 dash, okay. It is given that if Wronskian of 1 is equal to 1, then what is the value of Wronskian of 3 minus Wronskian of 2? Is it equal to 1, or option B 2 or 3 or 5? Okay. So the given differential equation is x square y double dash minus 2x y dash x minus 4 yx. If you know the Cauchy-Euler form, okay, I think you all knows the Cauchy-Euler form. The Cauchy-Euler form, from the Cauchy-Euler form, what is the Cauchy-Euler form? As if the differential equation of the form x square y double dash minus 2x y dash x minus 2 minus 4 yx. So we consider x as another variable, as a function of another variable, that is e to the power z, or z equal to log x. Okay. So after calculating, I think all you will know that xd will become d1 and x squared d square will become d1 into d1 minus 1, where d is equivalent to ddx and d1 is equivalent to the operator ddz. Okay. So x squared d square will become d1 into d1 minus 1, and minus 2xd is d1 minus 4. Simplifying this, we have d1 square minus 3d1 minus 4 into y. So the roots of d1 are, the auxiliary solutions of is 4 and 1. So the CF is c1 e to the power 4z. Okay. As d1 is a function of z, d1 is a function of z, the solution will be in the form of z. So the solution will be c1 e to the power, as the roots are distinct and real, so the form is c1 e to the power m1z plus c2 e to the power m2z. m1 and m2 are the roots. So here there are two roots, 4 and minus 1. So c1 e to the power 4, m1 is equal to 4z plus c2 e to the power m2 is equal to minus 1z. Okay. Now putting the value of z equal to log x. So this will become y is equal to c1 into x to the power 4 plus c2 into e to the power minus z is equal to 1 by x. So in the question, it is given that y1 and y2 are two linearly independent solutions. So I'm taking y1 as c1 x to the power 4 and y2 as c2 1 by x. Okay. So y1 is equal to c1 x to the power 4 and y2 is equal to c2 by x. The Wronskian of y1, y2, this formula is y1, y2, y1 dash, y2 dash. That is c1 x to the power 4, c2 by x. The derivative of c1 x to the power 4 is c1 into 4x cubed. The derivative of c2 by x is minus c2 by x square. Okay, if we calculate the determinant, we'll get minus 5c1 c2 x square. Now, what is given? Now, wx is equal to minus 5c1 c2 x into x square. Now, it is given that w1 is equal to w1 is equal to 1. So, if we put x equal to 1, w1 is minus c1 c2 1 square, that is 1. That means minus 5 c1 c2 is equal to 1. So the value of c1 c2 is minus 1 by 5. So wx becomes, the value of c1 c2 is minus 1 by 5, minus 5 and minus 1 by 5 will cancel, and the only term will be here is x squared. So the Wronskian of x is equal to x squared. Now put x equal to 3, the Wronskian of 3 is 3 squared, that is 9. Put x equal to 2, the Wronskian of 2 is 2 squared, that is 4. So Wronskian of 3 minus Wronskian of 2 is equal to 9 minus 4 is equal to 5. So the answer will be D. Okay. So these are some questions today we have discussed. In future, in later, I'll discuss some questions, another hard questions, which will surely help you in the competitive exams in future. Okay. So goodbye.